My name is Gilles Dubreuil. I am part of a group of Red Hat IBM engineers helping with Openshift migrations. Today I'm presenting the first release of CPMA, which is the Control Plane Migration Assistant to help manage information of an Openshift container platform cluster. But more specifically, CPMA can help us reuse configuration information and cluster-wide resources. So a common scenario is when migrating from OCP3 to OCP4, and this tool can help us by putting definitions of the source cluster control plane and also provide a detailed report about the cluster itself. So let's see how we can manipulate CPMA to use an OCP3.11 cluster as a source and to run CPMA against it to extract some of its definitions and also provide us with various information about the cluster, so it can help us with the porting. So let's get started by retrieving the tool itself. Alright, that's done. Then we're going to check out the release-1.0 branch. That's our reference today. And just run make to be sure that we can compile the tool. So that we're done with that here. So before we get started on the execution of the tool itself, we have to make sure we have proper access or the required access to our OCP3.11 cluster. So there's two parts to that. First of all, we need to make sure we have SSH access to that server, because we're going to use the tool in what we call the remote mode. So the tool can connect to the master node of that cluster and retrieve the various configuration files to extract information from it. So if SSH is not an option, then the files can be copied manually and made available to CPMA. So CPMA will retrieve the file locally. But we're going to use the remote mode. So we're going to check we can SSH to our OCP11 cluster. Oh, here we're using OCP11 version, but any version from OCP3.7 is supported. So we can SSH to that master node, and I just using that quick lab user here and check we have sudo access, so we can access the various configuration files. Normally, by default on the OCP, on an OCP installation, the root access is disabled through SSH, so that's why. Now the second part of the access requirement we have is make sure the Openshift command line interface or the OC tool can access the Openshift API. And the reason is CPMA relies on kubeconfig by default to communicate with the Openshift API. So once we log in, then CPMA can run smoothly. So I thought already ready. Oh, of course I'm not in the right place. So I'm going to go back to my machine and run OC logging against our cluster. Now we properly logged in, so good to go. The other thing is the user to access the API must have cluster admin role defined. So if that's not has been done before, then you need to basically must log in with the admin privilege user and add the role to the policy, which has already been done on this one. Basically consists on that command. And here it doesn't really make sense because I'm already been granted the role. So, but normally you run that as admin, of course, to grant the appropriate user that role. And the reason is because we access definition at the cluster level, and if we don't have that, then there will be a failure retrieving those objects. All right, so we're done with checking the access to the OCP3 cluster. The last thing we're going to look at is the object we're going to retrieve from OCP3, and then we're going to port across OCP4. So I'm going to make sure we've got like quota objects for this scenario defined on the OCP3 cluster. So if I do OC get cluster resource quota, we should get something here. There we go. There we go. So here we have a cluster resource quota definition. It's called cluster quota test. That's the name of the object, and then we have some definitions against it. So that's already been defined, and now we're going to look at the resource quota definition, which are defined per project or namespace. So if we go, I've got the namespace already created here, which is called quota test. So we're going to swap to that one. And now if I run resource quota, we should get a hit. There we go. So we're going to just look at the content of that object. There we go. So here we have the object demo quota defined as part of the object quota test namespace, and then we have quotas defined against it. So we're going to see that CPMA is going to find those objects and is going to retrieve them. So we'll be able to apply the generated manifest on the target cluster. So the purpose of CPMA is not to do any workload migration. Quotas are a bit of a sort of specific case and a bit across the line, but the cluster resource quota are definitely object defined at the cluster level. So now we can we're ready to run our tool. Just want to make sure I don't have any training config from previous tests, and now we are ready to go. So the first time you run the tool, it asks you for entering the parameters for the configuration, and we're going to go through that. By default, ask you if you want to save the configuration for future use. Say yes. As we said, we're going to work in remote mode. That means, again, CPMA is going to retrieve the files through SSH from the master node. So we're going to do that. Then we want to keep the default path for all those various configuration files that CPMA retrieves from CR-o, etcd, the master config file, the node config file, although it's not used at this stage, and the registry config file for the image definitions. As we've seen, CPMA relies on the kube config for accessing the Openshift API, so we want to use our local kube config file, and the tool can see that there are several contexts defined in the kube config. We want to use the first one here, which corresponds to our OCP 3.11 cluster, and this is the master node. Finally, for the SSH part, we want to use QuickLab user. That's the one we've been through. Default port is fine, and then we need to provide a path for that user private SSH key, which is stored just right there. And finally, this is the target folder on the local machine for all the retrieved data to be stored. So we use data. So now I'm interrupting the process here because I just want to show you the generated config file. So this is where all the settings the settings we have just entered has been stored. We can change any value there and go back to it later. And here we don't need to change anything. We just rerun the tool. Since the configuration file is available, it's not going to ask us anything. It's going to go straight into the extraction process. That should take only a few seconds. The OCP 3.11 here is pretty vanilla install. Besides few objects like the quotas we've created, there's nothing much more than that. So that should be quite quick. It's done. You can see we don't have any CI-o configuration here, so it has ignored that. Now, if we look into the file structure of that data subfolder, we can see three different kind of information. The first one is the fully qualified domain name of our master node, and all the files, subfolder and files underneath match the structure on the server. So that's all the files that have been fetched and stored locally. We can rerun the tool in local mode, so you won't go through that SSH part of the file fetching process again. And as I said, if SSHing to the master node is not an option, for some reason, then the files can be copied locally. The only thing that has to be done is respect the fully qualified domain name of the server, and then respect the same layout as on the server, so CPMA can find the files. Or alternatively, the path can be changed in the configuration file, as we've seen. So that's for the source configuration file information. So CPMA use that to retrieve the information available, see what can be ported on the OCP4 when it makes sense, and when it does, then it creates a file under the manifest folder, which contains the resource, and which can be reapplied as such on the OCP4. So if we look at one of them, like manifest, let's say cluster config, we can look at the OAuth file here. So We have two identity providers defined on our OCP3 cluster, and the two blocks here, and that has been extracted and regenerated in a format that is will be accepted by OCP4. And we also have the GitHub configuration for the GitHub identity provider. And we should have also look at our the cluster quota. Right, so here that should that correspond to the cluster quota definition we've seen before. Although the format is the same between OCP3 and OCP4, there is not much change there. Now the last part of the content of that data folder is the report. So there's two formats for the report. There is the JSON sort of, let's say, flat format. And then we have two blocks of information, so to speak, here. There is the cluster part where CPMA has retrieved all the objects that they define on the cluster, including the cluster level ones. So to give the user an exhaustive view of the content of that cluster. So there will be nodes, routes, pods, and so on. If we actually search for quota, we should find our cluster quota test object here, and we should also see the one defined on the namespace level. So this is the object quota demo we've seen earlier, which is part of the object quota test namespace. And then the other format for the report is HTML, which is much more user-friendly. And as you're going to see, I need to log out here, and I need to download that file on my local machine here, so I can show it to you. All right. So here, just reload the document, and we can see the two blocks here. So the component report has all the configuration information that the CPMA tool supports. So that's the control plane side of things. And some of them are not necessarily defined for that cluster, so you'll be empty. As we've seen, there is no CRI-O definition, but we've seen the auth part where we have the GitHub identity provider and the HT password defined. And here are some of the values specific to the OAuth. So basically the idea here is in an OCP3 cluster, there are things defined in a certain way, they are not defined in the same way or not at all on the OCP4 cluster, because the approach of building is radically different, especially using the operators. So the idea here is say, well, we have a value on the source cluster, and that value has no equivalent in OCP4, and then there is no way we can support that. And on the other hand, there will be some values that are not changed and exactly the same, or they could be partly the same, so it means it's supported but in a different way. So the idea is a tool to help the user from that perspective and saying, well, look, that forget about that one because this is done differently, and going to take the new approach, or yes, this can be ported, or some of those values are ported but not all of them. So it's sort of like the middle ground here. So when the confidence is 2, it's green. That means we know that it's completely like sort of a one-to-one relationship between the two, or we've been able to port that value to the equivalent on the other side. When it's not supported, it will be red and basically a confidence of 0. So that's for the control plane side of the information. Now the cluster report, as I said, is as exhaustive as possible to provide information of the cluster itself. So the resources. So here the user can have the big view, so to speak. So all the nodes, the namespace that has been created there, and for each namespace, it's broken down by sub objects. So to go back to our quota, for instance, we here have the list of all the quota broken down by namespace, and we should be able to see that there is an object quota test here. The object quota test is the namespace, and then we have the object quota demo that was created into it. So that's consistent. And we have also, at the cluster level, we have the resource quota, or it's called cluster resource quota defined, and then we find here our cluster quota test object with some of the definition that was assigned to it. So that's pretty much it for the report. And now the last part will be to show you that some of this manifest can be directly applied into targeted OCP4 cluster. So I'm going to go back to that demo area. And here we have all those generated manifests we've seen before. So first of all, I need to log to our OCP4 cluster. There we are. And let's say I want to apply that, actually it's created because the object doesn't exist yet. I want to create that cluster quota definition. So that's this one here. That's it. So if I do OC get cluster resource quota, our object is here, and we can retrieve the content of it. Layout, and we're good here. Now let's do the same thing for the resource quota at the namespace level. So let's get all the namespaces. And sorry, let's look at this object quota resource 1. So that's the name of the namespace. So what I'm going to need to do is create a namespace because that one doesn't exist. And well, if we try to run that thing, I think because the namespace object quota test doesn't exist, which is fine. We need just to create it. Can do that on the command line. And object quota test. Okay, now we can run has been created. So if we swap to that namespace, we should be able to get the list of resource quota defined at this level. And here we are. And if we retrieve it, we should find our. So that's pretty much the same thing for any other custom resource that has been created in those YAM file. Let's say for the authentication part, which is more the control plane side of thing, we should be able to do exactly the same thing. So we say, well, look, we have a bunch of authentication provider or identity provider that has been provided. We want to apply them here, and that's the configure auth. And I cannot create that because of subject basically modify the configuration, so it's apply. And that's it. Oh, sorry, that's what I'm doing here. There we are. So the GitHub definition has been updated in the cluster configuration. So we are good. And this is the end of the demonstration for CPMA release 1.0. And thank you for your attention.